So let's look at the factors that affect the rate of a reaction. So going back to the collision theory, whatever will lead to an increase in the number of effective collisions, not just collisions, but effective collisions, will increase the rate of the reaction. So most, not all of these, but most of the factors that affect reaction rates have to do with the collision theory. This first one does not. We call it nature of the reactants. Some things, just because of their nature, because of their properties, react faster than others. This has to do with ionization energy for metals, especially electron affinity for nonmetals. So an example would be sodium reacts much faster with water than does calcium. So both sodium and calcium react with water, but the reaction between sodium and water is much, much, much faster than the reaction between calcium water. Again, ionization energy for sodium is lower than the ionization energy for calcium, which makes sodium more reactive. And the more reactive the substance, the faster the reactions it undergoes. Reactions that involve breaking and forming of covalent bonds tend to be slower because, as you know, covalent bonds are the strongest type of chemical bond. And so a lot of energy is required to break those reactant particles apart, break the atoms apart in those reactants. And so those reactions tend to be a little bit slower. All right, so the first one that is affected by collisions is concentration. So it says this is an issue if the reaction is a homogeneous reaction. So remember, a homogeneous reaction is one in which everything involved in the reaction is in the same phase or same physical state. So anytime you have, technically it doesn't have to be a homogeneous reaction, you can increase the concentration of a couple things. Those being gases. If you increase the amount of gas in a container, that'll increase its concentration. That's going to lead to faster reactions. You can also increase the concentration of aqueous solutions. So the higher the concentration of the solution, the faster the reaction. So it says if the concentration is higher, then the reacting particles will collide more frequently. Therefore, higher concentrations produce higher reaction rates and vice versa. Now, something to be careful of, I didn't mention it before, but going back to what we talked about last lesson and the definition of rate. Rate is change over time. Don't confuse reaction rate with time. So increasing the concentration will lead to the reaction rate increasing. That's because the time that it takes for the reaction to occur decreases. So be careful with increasing reaction rates. That's one way to describe the reaction versus a faster reaction. Also another way of describing the reaction. Also less time for the reaction to occur. So those are all kind of ways of describing how fast, how long it takes for a reaction to occur. So don't say, one of my pet peeves is don't say that the reaction rate is faster. No, the reaction is faster. The reaction rate is higher. So just a little wordplay there. The factor that affects the rate of a reaction is surface area. It says this is usually an issue if the reaction is heterogeneous, meaning the reactants are in different phases. Says if the surface area is greater, then once again the reacting particles will collide more frequently. Like concentration, you cannot increase the surface area of anything. Going back to concentration, you cannot increase the concentration of a solid or liquid. They have constant concentrations. As far as surface area is concerned, you cannot increase the surface area of an ion. We're talking about things that are really, really, really small. Nor can you increase the surface area of a gaseous particle. Again, very, very small particle. So when we talk about increasing the surface area, we're talking about a solid or a liquid. So how do we increase the surface area of a solid or liquid? It says surface area is increased by decreasing the size of each solid or liquid particle in a fixed mass. So you take a chunk of some solid, break it up into smaller pieces. that's going to increase its surface area. So technically, we're talking about surface area to volume ratio. And so increasing the surface area will lead to more collisions. Something that's not really directly related to surface area of the particles, but mixing or stirring will also allow for more reacting particles to be able to come in contact with one another, thus increasing the rate of a reaction. That's why, even though it's not a chemical process, that's why we add, say, sugar to our coffee. We stir it so that that sugar dissolves faster. All right, next up, go and fill that out for number 5. Increased surface area leads to higher reaction rates, or I use the word greater here. Faster reactions, higher reaction rates. Another one related to the collision theory is temperature. Particles move more rapidly when the temperature increases. So this has 2 effects. Again, we're talking about increasing the temperature, maybe of a solution, maybe increasing the temperature of a gas, but usually it's kind of like increasing temperature of a solution. So a couple things happen when you increase the temperature of one or both of your reactants. One, the reacting particles will collide more frequently. So particles are moving faster, they're going to be involved in more collisions. And secondly, the reacting particles will collide with more force or more energy. Any guesses which one of the 2 has a greater impact on increasing the rate of a reaction? That there are more collisions or harder collisions? Again, go back to the collision theory. Not all collisions result in a chemical reaction. Those collisions need to be hard enough in order for the reacting particles to form products. So of the 2, B is more important than A, but they both apply. So increasing temperature increases the rate of the reaction. All right, so next up we have catalysts. Again, may be related to the collision theory, depends on the type of catalyst. So don't really like this definition, but we'll change it a little bit. It says a catalyst is a chemical that changes the rate of a chemical reaction. Now that word change implies that it can go either way. It can either increase or decrease the rate of a reaction. And it only goes one way. So catalysts are chemicals that increase the rate of a reaction. And so how do they do this? Catalysts are not involved directly in the reaction, or they sometimes can be. They're not, I shouldn't say they're not involved, they're not consumed. So a catalyst is something that you add to the reactants, allows the reaction to occur faster, but then that substance is produced as a product. So it's never consumed in the reaction. So catalysts increase the rate of a reaction by reducing the amount of energy required for the particles to react. Anybody remember what this is called? The energy that is required for a reaction to occur. This is called activation energy. So catalysts will lower the activation energy for a reaction. They provide an alternative pathway for the reaction to occur, an alternative pathway that has a lower activation energy. The lower the activation energy, the faster the reaction. We have catalysts in our bodies, chemicals that increase the rate of reactions. For example, chemical digestion is aided by these things called enzymes. You have things like amylase and lipase and nucleases. All these things that end in ase. If it ends in ase, it is an enzyme. And these enzymes are biological catalysts. All right, that concludes part 2 of lesson number 1 on reaction rates. Thanks for watching.